All right, ladies and gentlemen, welcome to Lesson 2 of your Probability and Statistics unit. This is going to explore the fundamental counting principle in a little bit more detail. So what I'd like you to do is, using your knowledge of the fundamental counting principle from the first lesson of this unit, please attempt the problem that is currently on the screen. Pause the video, attempt the problem, and then resume the video to see how you did. So, hopefully, based on what we did in the previous lesson, you would look at this problem and you would say to yourself, well, gee, there's 31 options, and because I have to choose 2 scoops, there should be 2 blanks being multiplied together to find the n value. So, 2 blanks, option 1 and option number 2 on the flavors. And notice that it does say different flavors, so they can't both be the same. That means we have 31 options for our first choice and 30 options for our second choice. So I would expect you to have 930 for your answer. However, this is not the correct answer because we need to divide that number by 2. Why? Well, because, for instance, 2 of those flavors undoubtedly are chocolate and vanilla. And since we're not looking at a situation where we're stacking these or anything like that, these 2 options here are the same. And using the same logic, all 930 options that the fundamental counting principle comes up with have a duplicate in the list, which means that in order to eliminate duplicates, we need to divide by 2, which means the actual answer to this problem is there are 465 options. Now, the big thing here is this question up at the top. This is what tells us what we're supposed to do. See, in this case, when we're looking at this problem, if we chose chocolate first and then vanilla, that was the same as us choosing vanilla and then chocolate, which means that order did not matter. And as a result, we had additional work that we had to do to get the correct answer. Now, that is the big question. So that comes down to, does order matter? That is a yes or no question. So we need to answer, what do we do in each case? Well, assuming that order matters, we do what is called a permutation count, which would be the notation NPR, which is available on almost every scientific calculator. The notation itself may vary slightly, and we are going to refer to your yellow TI-30XS2 multi-view calculators that you guys have as I do this lesson. So NPR, N is again our sample space size, and R, I really don't have a great way to define that yet. So I'm going to go with this definition for now, the number of items chosen. Now, NPR is defined as being n factorial over n minus r factorial. And that, quite frankly, is something that we need to talk about very briefly here, this symbol. Okay, that symbol is known as a factorial. And if you're not familiar with factorials, they're a very simple idea. If we had, for instance, 3 factorial, that is 3 times 2 times 1. If we had 5 factorial, it is 5 times 4 times 3 times 2 times 1. 9 factorial. I think we should be getting the pattern by now. Okay, basically what a factorial does is it multiplies any positive integer by every other positive integer with less value. It only works where n factorial only works where n is greater than or equal to 1 and a positive integer or natural number. Okay? So, Let's just look at an example, because that's about the best way for us to introduce this. Let's say we wanted to do 9 permeate 4. Okay, your calculator can do this for you, but here's the math behind what's happening. So that would be 9 factorial over 9 minus 4 factorial, which would be 9 factorial over 5 factorial, which is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by 5 times 4 times 3 times 2 times 1. Now, your calculator is going to carry out this actual calculation for you, but 5 down would cancel, and we would actually end up doing 9 times 8 times 7 times 6 and getting 3,024. Now, let's talk about how to have your calculator do that for you. What we do, so here are the calculator keystrokes down at the bottom. On your TI 30XS, is we put in the n value, which is 9. Then we hit the PRB button. You'll notice that the 3 options in the list, the first option is NPR, the second option looks similar, but instead of P it has C. Third option is factorial. We're only going to use that first option. So we're going to hit 1 to select NPR from the list. Then we're going to type in the second number, which is 4, and then hit enter. If you do this, you should get 3,024. Your screen should have 9 NPR4 on it when you hit enter. Okay? So that's what we do when order matters. We do a permutation count. When order does not matter, then we do a combination count. A combination count is that other notation you saw, NCR. N and R are still the same 2 values. And this time we end up with n factorial over n minus r factorial r factorial. So the extra r factorial means that NCR is always smaller than NPR. So again, let's just look at an example. We'll use the same 2 numbers we used a minute ago. We will do 9 choose 4, which is how that would be read. That would be 9 factorial over 9 minus 4 factorial 4 factorial. So that's 9 factorial over 5 factorial 4 factorial, which is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. Again, your calculator is going to carry out this calculation for you, but everything from 5 down would cancel with the 5 factorial on the bottom. Then please notice that 3 times 2 is equal to 6, so that would cancel, and 4 would cancel into 8, leaving 2. So the actual calculation that your calculator is going to carry out is 9 times 2 times 7, which would be 126. Now, if you type that into your calculator, your keystrokes would be, again, put in that first number, 9. Then we're going to hit the PRB for probability button. This time we're going to choose option 2, which is NCR, and then put 4 for the second number and hit enter. So just quickly, please do that. Make sure that you understand how to use your calculator to carry out these calculations. Again, you should get 126, the same answer we got by doing it longhand. Your screen, when you hit enter, should read 9 NCR 4. Okay, on the next screen are 4 problems that you are supposed to do with your calculator. Please type each of those 4 in, get an answer, and then resume this video to see how you did. So pause the video, try those next 4 examples, and then resume the video. Okay, 8 choose 3. So again, you should be typing in 8, then you should be hitting the PRB button, choosing option 2 because it is an NCR, typing in the 3, and then hitting enter. So 8, choose, the wrong button, there we go. 8, choose 3. You should have gotten 56. Okay, for the second one, 9, then hit the PRB button, choose option 1, then 3, and enter. So 9, permeate 3 should be 504. Okay, notice how much bigger the permeation is than the combination. That's a very common thing for the permeation to get really big where the combination really does not. So the next one, 12, PRB, it is a combination, so we choose option 2, 8, and then enter. So 12, choose 8 is 495. And finally, we type in 12, we hit the PRB button, select option 1 for a permutation, 5, and then enter. So 12 permeate 5 is a pretty big number, 95,040. So hopefully this has given you enough time to figure out how to use your calculator to carry out combination permutation problems on the calculator, because now we're going to advance to looking at a probability word problem and asking ourselves the question, does order matter? And then using the correct either permutation or combination count to determine the possible outcomes, the size of the sample space. So here's the first example. This reads the Florida lottery. Play the lottery in Florida. Player chooses 6 numbers of a possible 53 options. How many Florida lottery tickets are possible? So you have to ask yourself the question, does order matter? And here's how you should think about this. If a player chose the following numbers to be their numbers on the ticket, 2, 5, 12, 31, 40, and 50, those are all options. And there's 6 numbers that they've chosen. If a different player comes in and picks those same numbers in this order, they still have the same 6 numbers, which means they have the same ticket. So in this case, order does not matter. Doesn't matter what order the 6 numbers are selected, you'd still end up with the same ticket. So since order does not matter, we would use a what? Combination count. So we are going to do NCR. Now something to keep in mind is that N is always greater than or equal to R. So there are only 2 numbers in this problem, 53 and 6. Since N is always bigger, N is 53 and R is 6, meaning that we are doing 53 choose 6. Now this is the lottery, so we should expect to get a rather large number here. Again, keystrokes, 53, choose 6, we would hit 53, then we would hit our PRB button, choose NCR from the list, and then 6, and hit enter. That number is 22,957,480 possible tickets, which means you'd have a 1 in 22,957,480 chance of winning the jackpot. There may be lesser value items, but to get the full prize, you would have to match all 6 numbers, which is a 1 in 22,957,480 chance. Let's do another one. Coach Wills, that'd be me, has 25 players on his soccer team. How many lineups of 11 players can Coach Wills put onto the field if each position is different? So we ask ourselves, does order matter? Because that's the key. Now notice that I said each position is different. And I haven't even went on and said goalie's different from forward. So that means that, yes, order absolutely matters, which means we are doing a permutation count. Now again, there's only 2 numbers in the problem, 25 and 11. N is always greater than or equal to R, so N is 25 and R is 11, which means the answer to this question is 25 permeate 11. So we type that into our calculator using our keystrokes, choosing PRB from the list. So 25 permeate 11 And we get a rather shocking number, 1.779251443 times 10 to the 14th power. That is correct. The answer is so big that your calculator can't even fit the entire thing on the screen. So we would have to give an approximate answer here. Notice that what this means in scientific notation is that we have to move the decimal place 14 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We still need to go 5 more places. So we're looking at approximately adding 5 zeros to the end of our number, meaning that the answer, and this is the correct answer, is that Coach Wills, me, has 177,925,144,300,000-ish possible lineups to choose from. Now those numbers are not always going to be that big, but permutations get big really fast. So don't be shocked if you get a big number. You should be familiar with scientific notation, and if it happens, you should be able to deal with it by giving me an approximation. Okay, so let's do some easier ones. A department at Pythagorean Incorporated has 8 employees. How many different ways could the department head choose a group of 3 employees to attend a seminar? So we ask ourselves, does order matter? And this is kind of a complicated one. We need to think to ourselves, if we're one of those 8 employees, and we are chosen first to go to the seminar, versus getting chosen third to go to the seminar, is there any difference? And the answer to that question is no, because we're still going to the seminar. So order does not matter, which means we're doing an NCR. Again, n is always greater than or equal to r. There are only 2 numbers in the problem. So n is 8 and r is 3, meaning that our answer is 8, choose 3. So we would type that into our calculator, again choosing NCR from our probability list to carry out that combination count. 8, choose 3 would be 56 possible groups. Okay, last example. Again, you might pause the video, try it on your own, and then resume the video to see how you did. A radio contest has drawn 15 winners of a daily drawing and placed them into a second drawing, which has a grand prize, a first runner-up, a second runner-up, and a third runner-up. How many ways could they choose winners for the second drawing? So, we need to think to ourselves here, does order matter? And when we're dealing with prizes or placements, we need to think to ourselves, is there any difference between one prize and another prize? We have a total of 1, 2, 3, 4 prizes. And being the grand prize winner is very different from being the third runner-up. We don't get the same prize. So does order matter? Yes, it does. Which means we are doing an NPR, where N is the 15 people and R is the 4 prizes. Grand prize, first runner-up, second runner-up, third runner-up. That's 4 prizes. So we are doing 15 permeate 4. Again, we type in 15, then we hit our PRB button, select NPR from our list, hit 4, and then hit enter. Your screen should read 15 NPR 4. That would be a possible 32,760 possible ways that they could choose winners. Okay, that does it for lesson 2. Thank you very much for your time and attention.